Today I would like to discuss the system of linear equations. System of linear equations. In system of linear equations, system of simultaneous linear equations, there are three types of systems. Three types of systems based on number of equations and number of variables. Observe. If the system of m linear equations with n unknowns, m linear equations with n unknowns, the system of m linear equations with n unknowns is a11x1 plus a12x2 plus a1nxn equal to b1, a21x1 plus a22x2 plus a2nxn equal to b2, and so on, am1x1 plus am2x2 plus, and so on, amnxn equal to bm. Okay, these are m linear equations with n unknowns. Here, first equation, second equation, this is mth equation. Okay, m equations with n variables. The system of m equations with n variables are classified into three categories based on number of equations and number of variables. Suppose if m less than n, it is underdetermined system. Suppose if number of equations and number of variables are equal, then determined system. Suppose m greater than n, number of equations are more than number of variables, then overdetermined system. Okay, now the system of equations ax equal to b form, where a is known as coefficient matrix, this x is known as solution vector, this b is known as column vector, this column vector is nothing but b1, b2, bn values. Understood? Here a is m cross n matrix, x is n cross 1 vector, m is m cross 1 vector. Understood? This is the structure. Please remember, whether your system is underdetermined system or determined system or overdetermined system, whatever system is given, the solution procedures are two types. Based on number of equations and number of variables, you may classify into three categories, but the solution procedures for all three categories are only two. One is homogeneous system, another one is non-homogeneous system. Suppose in Ax equal to B, if B is 0, then it is called homogeneous system. If B is not equal to 0, then it is known as non-homogeneous system. So whenever you are solving a problem on system of equations, first you have to check whether it is homogeneous system or non-homogeneous system. Mr. Saini, please watch the recorded videos of previous lectures, then you follow from here onwards. Okay, if it is your first class, better to leave now. Please watch recorded videos of previous classes, then follow. Okay, now if the given system is underdetermined or overdetermined or determined, first you have to classify whether it is homogeneous or non-homogeneous. Okay, observe. First you draw the tree diagram. First I am giving the tree diagram. Okay, if it is second attempt, you can follow, no problem. First you draw the tree diagram, later I will explain with examples. Now, system of equations are classified into two categories. One is homogeneous, another one is non-homogeneous. You have to remember this diagram. Ax equal to 0 is called homogeneous. Ax equal to B, B not equal to 0 is non-homogeneous. The homogeneous system is always consistent. Consistent means possesses a solution. Sir, what about non-homogeneous? Non-homogeneous system is not always consistent. It may be consistent or it may be inconsistent. It may be consistent or may be inconsistent. Sir, when it is inconsistent, rank of A not equal to rank of augmented matrix AB. Rank of A not equal to rank of augmented matrix AB, the system is inconsistent. Inconsistent means no solution. Consistent means it possesses a solution. Sir, what type of solution? Next I will draw. Consistent means possesses a solution. Inconsistent means no solution. Okay. Now, so when it is consistent, rank of A equal to rank of augmented matrix AB, then it is consistent. Okay. Now, If it is consistent, it possesses either unique solution or infinitely many solution. Rudra, you will get it only by example. Okay? First you draw the tree diagram. I already told you, you note down tree diagram. Next I will explain with examples. Rank of A equal to rank of AB, then it is consistent. If it is consistent, it has two possibilities. Either unique solution or infinitely many solutions. If it possesses unique solution, rank of A equal to rank of AB equal to number of variables. If it possesses infinitely many solutions, rank of A equal to rank of AB less than number of variables. Rank of A equal to rank of AB less than number of variables, infinitely many solutions. Rank of A equal to rank of AB equal to number of variables, unique solution. Observe here. If the system is homogeneous, it has two possibilities. Either it possesses trivial solution or non-trivial solution. Trivial means zero solution. Non-trivial means non-zero solution. Sir, when it possesses non-zero solution, very simple. Rank of A less than number of variables. Rank of A less than number of variables, then non-trivial solution. Rank of A equal to number of variables, then trivial solution. Same thing you can write in another way. Sir, rank of A equal to n means that A not equal to 0. Yes. If rank is n, determinant is non-zero. If rank is less than n, then that A is 0. If determinant is 0, then the system possesses non-trivial solution. If that A is non-zero, then the system possesses trivial solution. Reverse. Please remember. If determinant is non-zero, then zero solution. If determinant is 0, then non-zero solution. Determinant is 0, then non-zero solution. Determinant non-zero, then zero solution. Understand? Simply you can understand that if set of vectors are dependent, then non-trivial solution. Set of vectors are independent, then trivial solution. Okay. Now, observe here. In the tree diagram, in the case of unique solution, I am writing one hint. In the case of unique solution, where you have unique solution? Here. Here, determinant of A not equal to 0. Saurabh, you can understand only when if I explain with examples. What is the difference between unique solution and infinitely many solution means? Rank of A equal to rank of AB equal to number of variables, unique solution. Rank of A equal to rank of AB, okay, it may not be visible. So less than number of variables. Rank of A, rank of AB are equal, less than number of variables. Avdesh, determinant 0 I have not written. That is your assumption. That is your assumption. I have not written. Why I have not written? I will explain. Suppose x plus 2y equal to 3. X plus 2y equal to 5. X plus 2y equal to 3. X plus 2x plus 4y equal to 6. Consider. Yeah, I am describing. I'll give the examples till you understand. Okay? Observe. In this case, 1, 2, 1, 2, xy, 3, 5. Here, 1, 2, 2, 4, xy, 3, 6. Avdesh, observe here. It is clearly in the form of ax equal to b. It is also in the form of ax equal to b. Okay. Now, what is det A here? 0. What is det A here? 0. Now, observe the difference. In both the cases, you have determinant is 0. Now, if you write augmented matrix AB, in this case, augmented matrix is nothing but write A and B combiningly in one matrix. 1, 2, 1, 2, 3, 5. Okay. Left side of this dotted line is A, right side of this dotted line is B. Combiningly, overall matrix is AB. Similarly, here, augmented matrix AB is 1, 2, 2, 4, 3, 6. Now, apply the operation. R2 minus R1. Here, R2 minus 2R1. Observe here. 1, 2, 3, 0, 0, 2. Here, 1, 2, 3, 0, 0, 0. Left side, you observe left side matrix. Tell me what is rank of A? Rank of A. अवधेश क्या सोच रहा है मैन? 1. What is rank of AB? Rank of AB. 2. Rank of A not equal to rank of AB in this case. Next case, right side 1. Tell me what is rank of A? 1. Rank of AB 1. Number of variables. Number of variables 2. In this case, you have infinitely many solutions. What about left side 1? What about left side 1? What is left side 1? Unica. Avadesh. rank of A and rank of AB are not equal. Not equal. Not equal matlab no solution. No solution. Okay. That's why I have not written determinant is 0. Catch my point? In the case of no solution, determinant of A is 0. In the case of infinitely many solution is also determinant value is 0. Please remember, in non-homogeneous system, in non-homogeneous system, in non-homogeneous system, in the case of no solution, we got determinant is 0. In the case of infinitely many solution also, you have determinant is 0. That's why by determinant is 0, you can't give any conclusion. Okay. Now, observe. But in the case of unique solution, clearly you can check determinant is non-zero or not. If determinant is non-zero, unique solution. If you have unique solution, determinant is non-zero. If determinant is non-zero, you have unique solution. If you have the system of equations possesses unique solution, then determinant of A is non-zero. That is necessary and sufficient. But in the case of no solution and infinitely many solution, in the case of non-homogeneous system, you should not verify determinant. Okay? You have to go by rank procedure only. Catch my point? Now, in the case of homogeneous system, no problem. In the case of homogeneous system, determinant 0, no non-trivial solution. Determinant non-zero, trivial solution. No problem. Understood? Laksh, I explained, I told you clearly. In the case of unique solution, 100% determinant of A is non-zero. You are in confusion. Okay. Now, I am explaining with examples one by one. After solving 3-4 problems, you will get some idea. Kameshwar, you are attending second time. That's why it is so simple. They are attending first time. That's why they have so many doubts. Right. Observe. First example. Suppose the given system is x plus y equal to 0, y plus z equal to 0, x plus y plus z equal to 0. First, you have to check whether your system is homogeneous or non-homogeneous. Homogeneous, very simple. Homogeneous means just you have to find rank of A. Okay, observe. First, you write the given system of equations in matrix form. One one zero 0 1 1 1 1 1. Okay. Now apply the operation R3 minus R1. to reduce the matrix in echelon form, because I have to calculate rank of A. Now 1 1 0 0 1 1 1 minus 1 0 1 minus 1 0 1 minus 0 1. X Y Z 0 0 0. Observe here. Is it in echelon form? It is clearly in echelon form. It is clearly in echelon form. Number of zeros before non-zero element are in increasing order when you move row by row. Rank of A is 3. Number of variables 3. Rank of A equal to number of variables. Therefore, trivial solution. Trivial solution means zero solution. Zero solution means every variable value equal to 0. Every variable value equal to 0. Every variable value, every unknown value equal to 0. X value 0, Y value 0, Z value 0. Sir, how do we know that? Simple. Write the equations by using this. By using this, you write the equations. Write the equations. X plus Y equal to 0. The equations are X plus Y equal to 0. Next, Y plus Z equal to 0. Third row gives us X, Y, Z. Third row gives us Z equal to 0. This is called 1. This is 2. This is 3. Substituting Z equal to 0 into Y equal to 0. Substituting Y equal to 0 in 1. X equal to 0. Finally, X value 0, Y value 0, Z value 0. Understood? That's why the system possesses zero solution or trivial solution. So in the case of trivial solution, if you verify determinant value is non-zero. If you verify determinant value of A, 100% that A is non-zero. Okay. Gauravi, this is the first example. I have to explain all possibilities. Okay. While solving problems in the examination, if it is homogeneous system, better to check determinant. If determinant is non-zero, trivial. Determinant is 0, then non-trivial. Okay? Right. Kameshwar, if it is non-homogeneous system, don't go for determinant technique. If it is homogeneous system, determinant technique is the best technique. If it is non-homogeneous system, rank procedure is the best procedure. Okay? Now, let me explain. Next example. Mishra, after completion of the examples, you will get the clarity. I will explain in different directions. Okay? You don't worry, just you concentrate on the content. Enough. Next example. Solve x plus y plus z equal to 0. X plus 2y plus 3z equal to 0. X plus 4y plus 7z equal to 0. Here the system is homogeneous. Whenever system is homogeneous, first you have to write in matrix form. Ax equal to 0 form. 1 1 1 1 2 3 1 4 7 x y z 0 0 0. Is it in echelon form? No. Apply the operation. R2 minus R1, R3 minus R1. By applying these two operations, you will get 1 1 1, 1 minus 1 0, 2 minus 1 1, 3 minus 1 2, 1 minus 1 0, 4 minus 1 3, 7 minus 1 6, x y z 0 0 0. Next, Avdesh, not 3R1, 3R2. R3 minus 3 times of R2. Now, 1 1 1, 0 1 2, 0 0 0, x y z 0 0 0. Observe here, what is rank? Rank of A. Rank of A is 2. Number of variables 3. Rank of A is less than number of variables. Rank of A is less than number of variables. Therefore, non-trivial solution. Sir, what is non-trivial solution? How to get non-trivial solution? I am explaining. Please remember, rank is 2 because number of non-zero rows are 2. These two non-zero rows gives two independent equations. What are the equations? You write. Number of non-zero rows in echelon form is called rank. That's why rank is 2. Okay. Observe. The equations are विकास क्या पूछ रहा है जी? हाँ, थोड़ा सोचना. ये मैथमेटिक्स क्लास में x y z are called variables. The equations are x plus y plus z, x plus y plus z equal to 0. Next, second row gives us not y plus z, y plus 2z, y plus 2z, y plus 2z, y plus 2z equal to 0. Called it 1, called it 2. Okay. What is the meaning of non-zero solution? How it generates entire process I am explaining. Concentrate here. Z is not zero. Who told you Z zero? Here we have only two equations. Okay. Now concentrate. Number of variables are 3, but number of equations are only 2. If you have 3 equations with 3 variables, you can solve easily. But number of equations are 2, but number of unknowns are 3. That's why you have to write free variables. Free variables equal to total number of variables minus rank of A. Okay. 3 variables with 2 equations. 100% solvable. How to solve it? I am explaining. Total number of variables minus rank. Total number of variables are 3. Rank of A is 2. Therefore, 3 minus 2, 1. So, one variable is free variable. Sir, which one? Among 3, you can take any one. Either X or Y or Z. Because we have 3 variables. Okay? Nandini, कैसे आए? ये रो को एक कॉलम से मल्टीप्लाई करने है तो एक इक्वेशन आएगा. A second row multiplied with this column, you will get second equation. Okay? Now, you got one free variable. So, that free variable or independent variable, you have to take one variable, either X or Y or Z. Let us take Z is equal to K. If you would like to take Y equal to K, you can take, no problem. Now, substituting Z equal to K in equation 2, you will get Y equal to minus 2K. Substituting Z equal to K, Y equal to minus 2K in equation 1, then you will get X minus 2K plus K equal to 0, X equal to K. Therefore, X is equal to K, Y equal to minus 2K, Z is equal to K. Suppose if you take K equal to 1, then you will get X equal to 1, Y equal to minus 2, Z equal to 1. K equal to minus 1, X is minus 1, Y is 2, Z is minus 1. So, different values of K, we can generate how many solutions? We can generate infinitely many non-zero solutions. You can take any value. K means arbitrary value, arbitrary, a parameter. Understand? Okay. So, different values of K, you can generate different solutions. How many solutions? Infinitely many solutions. That's why the system possesses infinitely many solutions or non-zero solutions or non-trivial solutions whenever rank is less than number of variables. That is main point. Sir, when rank is less than number of variables, why it generates infinitely many solutions? Simple logic. Whenever rank is less than number of variables, number of independent equations are less than number of variables. Whenever number of independent equations are less than number of variables, you have to introduce a free variable. Whenever free variable come into the picture, system generates infinitely many solutions automatically. That is the logic. Okay. Next. Now I am explaining non-homogeneous system. Ravi Ranjan, yesterday I have explained you that concept. Again they are asking. And that is their problem. Yesterday I told you clearly, determinant procedure gives set is independent or not. But rank procedure gives us how many number of independent vectors. That's why if you want to know how many number of independent equations, you have to go for rank. Okay, rank gives you idea about number of independent equations. In this example, rank 3. So number of independent equations are 3. Number of variables are 3. Number of independent equations and number of variables both are equal. Therefore, you have 3 equations with 3 variables. If you have 3 equations with 3 variables, 100% trivial. Suppose rank less than number of variables, because in this example number of independent equations are 2 because rank is 2. Number of independent equations are 2. Number of variables are 3. There is a shortage. Number of independent equations are 2. Number of variables are 3. There is a difference. That difference is nothing but free variable. Okay, because of that free variable, because of that parameter, because of that arbitrary constant, the system generates infinitely many solutions. Not only one solution, infinitely many. That's why we can say that the system possesses non-trivial solution or non-zero solution or infinitely many solutions. What is the logic behind this? I will explain geometrically. You can visualize. Observe. Suppose I have given 3 equations. अरे नितिन, minor method हमने छोड़ दिया. You are talking about minor method, rank निकाल सकते हैं. If you apply minor method, can't you get rank? वो story कल और परसों खत्म हो गया. By using minor approach, you can find out rank. 100% you can find out rank. But process is lengthy. Same message you have posted 3 times. That's why watch the recorded video. Visiting professors not allowed. You watch the recorded video and come back. Observe. Non-homogeneous system. Suppose I have given 3 equations. Suppose I have given 3 equations. You are going to solve. For what? To find solution. Okay. So 3 equations are provided with 3 variables. You have solved it. You got x value, y value, z value. What is that value? X value, y value, z value? Simple. Any equation in the form of ax plus by plus cz equal to d represents geometrically a plane. Okay, so I have given 3 equations means I have given 3 planes. You are going to find out point of intersection of 3 planes. The point of intersection of 3 planes. Okay, suppose I have given three equations. The three equations are like this. Yeah, non-homogeneous system. Three equations are intersecting like this. It means three planes are intersecting like this. So here, do you have any common point of intersection? Two planes are intersecting at this point. These two planes are intersecting at this point. These two planes are intersecting at this point. All three planes are intersecting at any point. There is no point of intersection. There is no point of intersection means it has no solution. Because there is no common point of intersection. If there is no common point of intersection, there is no solution. Okay? Suppose if three planes are intersecting like this, three planes are intersecting like this, do you have any common point of intersection? Yes, you have one common point of intersection, one and only one point of intersection. One and only one point of intersection is nothing but one and only one solution. That one and only one solution is nothing but unique solution. That is geometrical meaning of unique solution. This is no point of intersection, that's why no solution. That is called inconsistent system. Suppose three planes are intersecting like this. Your notebook. This is page number 1. This is page number 2. This is page number 3. Suppose if you take one notebook, each page is a plane. You have 100 pages. All 100 pages are intersecting along this axis. Along this axis. So, how many points of intersection along that line? On the line, you have infinitely many points. Catch my point? So, infinitely many point of intersections, that is called infinitely many solutions. So each page is a plane. You have 100 pages, so 100 planes. What is point of intersection of 100 planes? One line. On the line, how many points you have? Infinite points. So infinite number of points satisfies all these 100 planes. That means you have infinitely many solutions. That is the geometrical view. Catch my point? विकास आप 10 बार ये वीडियो वॉच कर सकते हैं. आई हैव एक्सप्लेन्ड ए नोटबुक एग्जाम्पल, और एक बार एक्सप्लेन कर दीजिए. नाउ एग्जाम्पल्स ऑन नॉन होमोजेनियस सिस्टम. कमलेश, वन लाइन बट इनफाइनाइट पॉइंट्स मींस वन लाइन पे कितना पॉइंट्स हैं? कमलेश कुमार, वन लाइन पे कितना पॉइंट्स हैं? इनफाइनाइट पॉइंट्स ना. दैट्स व्हाई एवरी पॉइंट इज ए सॉल्यूशन. इनफाइनाइट पॉइंट मतलब इनफाइनाइटली मेनी सॉल्यूशंस. Now, non-homogeneous system. For example, x plus y plus z equal to 4, x plus 2y plus 3z equal to 6, 2x plus 3y plus 4z equal to 10. Now, it is a non-homogeneous system. Whenever non-homogeneous system is provided, first you write in matrix form 1, 1, 1, 1, 2, 3, 2, 3, 4, x, y, z, 4, 6, 10. It is in the form of ax equal to b, where b is non-zero. Okay. Now, I have given the tree diagram. Whenever non-homogeneous system is given, you have to calculate rank of A as well as rank of augmented matrix AB. Rank of A equal to rank of augmented matrix AB equal to number of variables, then unique solution. Rank of A equal to rank of AB less than number of variables, infinitely many solution. Rank of A not equal to rank of AB, no solution. Okay, that's why I am going to write. Please remember, Kamalesh, no solution alag hai, zero solution alag hai. You should not talk about zero solution in non-homogeneous system. No solution means there is no possibility. Zero solution is every variable equal to zero. Don't compare. If you compare, you will be confused. Simple. Zero solution is a case of homogeneous system. Don't merge it. Non-homogeneous system has three possibilities: either no solution or unique solution or infinitely many solution. Okay. Now, Mr. Saini, you are asking too much. If you interchange two rows, how variable values changes? Huh? Before writing the comment, first you think. First you think at your level, then post. System of equations are developed by three variable values. If you interchange whatever operations you are doing, how variable value changes? Variable values are fixed. One student may apply R2 minus R1, another student may apply R3 minus R2. It doesn't matter. Elementary operations does not change the rank. Now, augmented matrix AB. One, one, one. 1, 2, 3. 2, 3, 4. That is matrix A. Matrix B, 4, 6, 10. Left side of this line, dotted line, you have matrix A. Complete matrix is augmented matrix AB. Okay. Sir, what is difference between matrix A and matrix AB? Matrix A is here 3 cross 3. Augmented matrix AB is 3 cross 4. What is the difference between A and AB? Augmented matrix AB consisting one column extra. Okay. This column extra. Then A. Himanshu means Himanshu. Augmented matrix means augmented matrix only. That is the name of the matrix. Okay. A and B combiningly we are going to write in one matrix. That matrix is called augmented matrix. Observe. Apply the operation, because I have to reduce augmented matrix AB in echelon form to get rank of A as well as rank of AB. That's why R2 minus R1, R3 minus of R1 plus R2. 1, 1, 1, 4. 1 minus 1, 0. 2 minus 1, 1. 3 minus 1, 2. 6 minus 4, 2. Okay, next. 2 minus 2, 0. 3 minus 3, 0. 4 minus 4, 0. 10 minus 10, 0. Now, what is the rank of A? Rank of A means left side of this line. Number of non-zero rows are 2. Rank of AB. Whenever you are writing rank of AB, you have to look at complete matrix. Last row is 0 row. That's why rank of AB is 2. Number of variables. How many number of variables in your system? X, Y, Z. 3. Rank of A equal to rank of AB less than number of variables. Therefore, infinitely many solution. Rank of A equal to rank of AB less than number of variables. Therefore, infinitely many solutions. Okay, whenever rank of A and rank of AB are equal and less than number of variable comes, you have to introduce the free variables. So how many free variables you have? Total number of variables minus rank. Total number of variables are 3. Here some students will question, sir, shall I take rank of A or rank of AB? Both are equal, then only you are going to write, na? That's why rank of A is 2, rank of AB is 2. Then only you are going to get a solution. That's why 2. You can write any one because both are equal. The difference is 1. Right. The equations are what are the equations? Many solutions in non-homogeneous, non-trivial in non-homogeneous, all are same. Raju Kumar, all are same. No difference. Okay? The equations are x plus y plus z equal to 4. Y plus 2z equal to 2. Now, x plus y plus z equal to 4, y plus 2z equal to 2. We have only 2 equations, but 3 variables. That's why one variable is free variable. Let us take one variable. You can take any one, but we have one practice. Let us take z equal to k. If you substitute here y equal to 2 minus 2k, substituting z equal to k, y equal to 2 minus 2k in equation 1, x equal to 2 minus 2k plus k, 2 minus k, and right side 2 plus k. Now, x is 2 plus k, y is 2 minus 2k, z is k. Now, x, y, z can be written like this. 2 plus k, 2 minus 2k, k. 1 minute, observe. This can be written as, concentrate here, 2, 2, 0 plus k into coefficients of k. What is coefficients of k here? 1. Here minus 2. Here 1. Like this. Now, different values of k, you can generate different solutions. Okay? Different values of k, we can get infinitely many solutions. Sometimes in the options they used to give more than one solution, infinitely many solutions, not finite number of solutions. Now, previous slide. Because this one or previous one, which one? Aniket Sharma. If k ka value 0 hai to total variables values will become 0 na? Then how non-homogeneous system will be balanced? 0 equal to some value will come. If you put 0, 0, 0 here, 0 equal to 4 will come. Catch my point? Avdesh, geometrical approach is only for your understanding purpose. Questions ke liye nahi. I have explained geometrical approach. What is going on here? Okay, for better understanding. Mathematical approach is different, visualization is different. In examination point of view, your questions are given in the form of mathematical approach only. K arbitrary means non-zero. Any non-zero value you can put. Huh? Understood? Now, no Sandeep, I won't take in future also. Okay, I'm not going to teach aptitude. Now, observe DMS. I am going to start from May first week. Mukherjee, first concentrate here. All the remaining questions we can discuss at 11:30 p.m. Okay, now come here. In previous examples, I have written free variables. That free variable concept is nothing but nullity. It has different names. All the terminology I am giving here. Concentrate. Note. Free free variables or independent variables. Independent variables are number of independent solutions or nullity or dimension of null space. All the names are different, but underlying concept is same. Equal to total number of variables minus rank. Independent variables are independent solutions or nullity or dimension of null space or dimension of space of solutions. Nothing but total number of variables minus rank. You have to remember only one line. Rank plus nullity. Rank of A plus nullity of A equal to total number of variables. This is known as rank and nullity theorem. Rank of A plus nullity of A equal to rank of matrix A and nullity of matrix A equal to total number of variables. In another way, while solving problems, we are going to use simple technique. Total number of variables are nothing but total number of columns. Total number of variables are nothing but total number of columns. Here I have to explain one point clearly. Some students get confused. Concentrate here. Sir, total number of variables equal to total number of columns means variable is a column, variable is not a column. But sir, you have written, I have written number of variables equal to number of columns. What is the logic also I will explain. I never said column is a variable. Here we have system of equations. M equations with n variables. Whenever you are going to write nullity of A means nullity of matrix A, Chaudhary. Nullity of matrix A. Rank of matrix A plus nullity of matrix A equal to total number of variables. Nullity means free variables. That story only we are talking now. Concentrate. Observe. Number of columns equal to number of variables. Number of columns equal to number of variables. Sir, why it is so simple? If you write the given equations in matrix form, first column you are going to maintain coefficients of x1. Second column coefficients of x2. Third column coefficients of x3. Nth column you are going to write coefficients of xn. That's why while solving problems we will say whenever you require number of variables, just count number of columns. Where? In coefficient matrix A. In coefficient matrix A, if you count number of columns, n columns, that means in matrix A you have n columns, therefore in solution vector you have n rows. Each row is a variable, na? X1, X2, X3, like. That's why always you have to count columns. Always you have to count columns in coefficient matrix A. Number of columns in A gives you idea about how many variables in your system. Don't get confused. Number of columns equal to number of variables. If you have 3 columns, your system has 3 variables. That is the meaning. Column is not variable. Column gives you idea about variable. Okay? Now, Are Chaudhary, nullity of A matlab only I have explained here, na? 5 points I have given. Sir, what is nullity means? Now, observe next problem. I would like to explain basis concept in this problem. Yeah, by using system of equations, you can write basis. For example, x1 minus 2x2 plus x3 plus x4 equal to 0. 2x1 minus 4x2 plus 2x3 plus 2x4 equal to 0. It is a homogeneous system, na? It is a homogeneous system or not? Now, first you write the given equations in matrix form. 1 minus 2, 1, 1. 2 minus 4, 2, 2. I have to write 2 here. 2x4, 2. Now, x1, x2, x3, x4 equal to 0, 0. Ax equal to 0 form clearly. Okay? Now, apply the operation because I have to reduce matrix A in echelon form to get rank of A. Because to solve homogeneous system, Ax equal to 0 form, to solve homogeneous system, the necessary condition is rank of A less than number of variables. Okay? R2 minus 2 times of R1. Now, 1 minus 2, 1, 1, 0, 0, 0, 0. x1, x2, x3, x4. Now, what is rank? Here, number of non-zero rows in A, 1. That's why rank of A is 1. Number of variables. Number of variables, 4. Now, difference, 3. Nullity is 3. Free variables are 3. Sir, which 3? You can take any 3. First, you write the equation. x1. First row, with the help of this non-zero row, I am going to write the equation. x1 minus 2x2 plus x3 plus x4 equal to 0. Okay? Now, you have only one equation. You have 3 free variables. Sir, which 3? You can take any 3. You take it. Let us take. There is no lag, Raju. You refresh your system. Come here. Don't divert the students. I am explaining very seriously. This is a dry concept. Please concentrate. Don't deviate from the concept. Concentrate here. You have only one equation, 4 variables. In that 4, 3 variables are free variables. 3 variables are free variables. Sir, which 3? You can take any 3. I am taking x1 equal to k, x2 equal to t, x3 equal to s. Three free variables we have, that's why I have taken 3 parameters. You can take lambda 1, lambda 2, lambda 3 also, no problem. Okay, I have taken k, t, s. Okay, substitute here. K minus 2t plus s plus x4 equal to 0. Now x4 equal to minus k minus s plus 2t. Understood? Understood? Now x1 is k, x2 is t, x3 is s, x4 is minus k minus s plus 2t. Now the solution vector x, y, z, 1 minute, x1, x2, x3, x4, x1, x2, x3, x4 equal to k, t, s, fourth one, minus k minus s plus 2t. 1 minute, observe. 1 minute, observe. I am going to write this solution vector in the form of k into 1 column vector plus t into 1 column vector plus s into 1 column vector. Just simply you have to write coefficients of k, coefficients of t, coefficients of s. Observe first variable. First variable k. What is coefficient of k? 1. Second variable, do you have k? No. 0. Next 0. Next minus 1. Do you understand this step or not? Nothing I have done. I have written coefficients of k. 1, 0, 0, minus 1. Next. What about coefficients of t? Now, coefficients of t, 0, because there is no t in first row. Second row, there is t, whose coefficient is 1. Third row, there is no t, that's why 0. Fourth row, minus 1. Sorry, plus 2. T coefficient. T coefficient. T coefficient is plus 2. Next. What about S coefficients? 0, 0, 1, minus 1. Understood? Understood? Now observe. Beautiful concept. Here, all these column vectors, you have 3 column vectors. All these 3 column vectors are developed by free variables k, t, s. All these 3 column vectors are developed by 3 free variables k, t, s. Now the basis is nothing but write all these column vectors in this set. In this set. 1 0 0 minus 1 0 1 0 2 0 0 1 minus 1. All these three column vectors are linearly independent. Another point I have to clarify. This basis is consisting only three independent vectors. Look at the vector. Look at the vector. In each vector, how many components you have? How many components you have? 1, 2, 3, 4. 4 components. Actually, your vector space is R power 4. Your vector space is R power 4. That's why your vectors are with 4-dimensional. But you got your bases with only 3 vectors. That's why you have to understand one point. Sorry, Nikhil. Not R cube, Baba. R power 4. Vector spaces of R power 4. But you have only 3 independent vectors in your basis. That's why you can say that this is subspace. This is only subspace, not spanning. It won't span. Okay, it will give only subspace of your vector space. What is the difference? Yesterday I have given one example. Their vector space is R cube. Basis is also consisting 3 independent vectors for R cube. Clear? That's why you can say that it spans. But here you have 3 vectors of dimension 4. Your vector space is of dimension 4, but you have only 3 independent vectors. That's why it is only subspace. It is only subspace. Catch my point? So basis is basis for the subspace of R power 4. Next, Ravi. कितना components हैं इधर? You have 4 components ना? 4 components ना? 4 components means you require 4 independent vectors, but you have only 3 independent. That's why I have mentioned subspace. You have one previous gate question on this concept. Observe. Find the basis. राजू कुमार, आपको कुछ भी समझ में नहीं आएगा, ये केवल क्वेश्चन लिखेगा आपने. Find the basis and its dimension. Whenever topic is going on seriously, you are posting one question. You are diverting all the students. Find the basis and its dimension by solving x1 plus x2 plus x3 equal to 0. Find the basis and its dimension by solving x1 plus x2 plus x3 equal to 0. Observe here, only one equation, 3 variables. So, if you write in matrix form 1, 1, 1, x1, x2, x3 equal to 0. What is rank? Rank is 1. number of variables 3, free variables 3 minus 1 2, free variables are 2. In among x1 x2 x3 you have to take 2 variables as free variables. Choice is yours. You can take either x1 x2 or x2 x3 or x1 x3. Okay, now let us take x2 equal to k, x3 equal to t. The equation is x1 plus k plus t equal to 0. Then automatically x1 will be minus k minus t. Okay, now x1 x2 x3 is minus k minus t, k t. Take k common, minus 1 1 0 plus t common, you will get minus 1 0 1. Understood? So now what is the basis? The basis is involving only two vectors. K coefficient is minus 1 1 0 and minus 1 0 1. Here, how many independent vectors in your basis? Only 2. But look at the dimension. 1 2 3. That's why it is a basis for the subspace of RQ, because it has 3 components. Understood? Now Manish, excellent observation. Number of free variables equal to number of independent vectors in the basis. Excellent. Because the vectors are generated by free variable only there. How you are going to generate these vectors? These vectors are generated by free variables only, na? So number of free variables equal to number of vectors in the basis. It is 100% correct. Yesterday we have covered problems till system of equations. All the problems on rank concept we have covered. I think this problem also we have solved, right? Now consider the following equations. This system has infinite number of solutions if, in which case the system has infinite number of solutions. It is a non-homogeneous system or homogeneous system. First you cross check that. Homogeneous or non-homogeneous? Non-homogeneous. Whenever non-homogeneous system is given, the best method is rank procedure. Okay? Consider the augmented matrix AB. One, 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 three. One. Y coefficient is 0. That's why 1, 0, AB. X coefficient is 0. So 0, 1, 2, 3. Understood? Now, I hope you know how to write this augmented matrix AB. Okay? Now R2 minus R1. 1 minus 1, 0, 0 minus 1, minus 1, A minus 1, B minus 3, 0, 1, 2, 3. Now, R3 plus R2. 1, 1, 1, 3. 0 minus 1, A minus 1, B minus 3. 0 plus 0. 1 minus 1, 0. A minus 1 plus 2. A plus 1. 3 plus B minus 3. B. Given that Ax equal to B has infinitely many solutions. Generally, infinitely many solution is possible only when rank of A equal to rank of AB less than number of variables. Actually, in this problem, how many number of variables you have? Number of variables equal to 3. If number of variables are 3, rank must be less than 3. Rank must be less than 3. When it is possible? When it is possible? It is possible only when this entry is 0, this entry is also 0. A plus 1 is 0 and B is 0. A plus 1 equal to 0 means A equal to minus 1, B equal to 0. A is equal to minus 1 and B equal to 0. Okay? Understood? Observe next problem. Consider the system of linear equations x1 plus 2x2 equal to b1. All these equations, total we have 5 equations. All are non-homogeneous. That's why the system is non-homogeneous. That's why first I am writing augmented matrix AB. Augmented matrix AB. One, two, two, 4, 3, 7. B1, B2, B3. 3, 9. 3, 9, B4. Okay, we have to apply the operations. R2 minus 2 times of R1, R3 minus 3 times of R1, R4 minus 3 times of R1. By applying these operations, you will get 1, 2, B1, 0, 0, B2 minus 2, B1, 3 minus 3, 0, 7 minus 6, 1, B3 minus 3B1. Next, 3 minus 3, 0, 9 minus 6, 3, B4 minus 3B1. Is it in echelon form? Is it in echelon form? No. Okay. To reduce the matrix in echelon form, apply the operation R2 interchange with R3. If you interchange R2 and R3, because in R2 you have 2 zeros before non-zero element. In R3 you have 1 zero. That's why I am going to interchange R2 and R3. You'll get 1, 2, B1, 0, 1, B3 minus 3B1, 0, 0, B2 minus 2B1, 0, 3, B4 minus 3B1. Observe here, it is not in echelon form. Now apply R4 minus 3 times of R2. By applying this operation, you'll get 1, 2, B1, 0, 1, B3 minus 3B1, 0, 0, B2 minus 2B1, 0, 0, because 3 minus 3 na 0, B4 minus 3B1 minus 3B3 plus 9B1. That is nothing but B4 minus 3B3 plus 6B1. Verify now. Is it in echelon form? Clearly. Rank of A is 2. Rank of A is 2. Sir, what about? Dekhu. Why not interchange R2 and R4? If you want to interchange R2 and R4, you interchange. Nothing is wrong. Rank of AB is 4. Namita, read the problem first. Which of the following conditions ensures that a solution exists? If you take rank of AB 4, then gone. Rank of A and rank of AB are different, inconsistent ho jayegi. So you have to get a solution. How to get a solution? Rank of A and rank of AB must be equal. Here rank of A is 2. Rank of AB must be 2. Rank of A is 2. Therefore, rank of AB must be 2 to get solution. Therefore, first read the problem, then understand, then apply. Rank of A is 2. Rank of AB must be 2 because he has mentioned that the system possesses a solution for which of the following conditions. That's why rank of AB must be equal to 2. It is possible only when it is possible only when this entry equal to 0, B2 minus 2B1 must be equal to 0, and B4 minus 3B3 plus 6B1 must be equal to 0. These two conditions must be satisfied. Not any one of them. Both the conditions must be satisfied. B2 equal to TB1 and 6B1 minus 3B3 plus B4 equal to 0. 6B1 minus 3B3 or 3B2 na? 1 minute. 3B3. 3B3 means 3B3 plus B4. Last option. Correct. Understood? Next problem. It is concept based question. A is 3 cross 4 matrix. Ax equal to B is an inconsistent system. Then highest possible rank of A, whether option C or option B, we have to decide. 100% answer is not 4 because you never get rank 4 in this case. Okay, either answer is 1, 2 or 3. We have to decide. Concentrate here. This is first hint. This is first hint. Ax equal to B is inconsistent system. This is second hint. With the help of these two hints, we have to solve the problem. Concentrate. While I am explaining, concentrate. A is 3 cross 4 matrix. It is given in the data. Okay. Now my question is, if A is 3 cross 4 matrix, what about AB? I am talking about augmented matrix only. What about the augmented matrix AB? Tell me now. Is it 4 cross 4? Is it 4 cross 4 or 3 cross 5? 3 cross 5. Why it is so? The difference between A and augmented matrix AB is one column. One column extra than A. That's why if A is 3 cross 4, then AB would be 3 cross 5 automatically. Okay. Now, this is extra column. Because of this extra column, here columns are 4, here columns are 5. I saw. Now, if augmented matrix AB is 3 cross 5, what is maximum possible minor of AB? What is maximum possible minor of AB? The maximum possible minor of matrix AB equal to 3 cross 3. If the maximum, concentrate please, if the maximum possible minor of AB is 3 cross 3, what is maximum possible rank of AB? Maximum possible rank of AB equal to 3. This is not the answer. Sir, in the problem they have questioned highest possible rank of A. You have calculated maximum possible rank of AB. Yes, it is equation 1. It is equation 1. With the help of this second hint, I got equation 1. What about first hint? Ax equal to B is inconsistent system. If given that Ax equal to B is an inconsistent system, if the system is inconsistent, rank of A not equal to rank of AB, called it equation 2. Now what you have to do, you have to verify or you have to compare equation 1 and equation 2. What is conclusion by equation 1? Maximum possible rank of AB is 3. What is equation 2? Rank of A not equal to rank of AB. Rank of A not equal to rank of AB. Maximum possible rank of AB is 3. If you compare these two statements, from 1 and 2, we will get one conclusion. What is our conclusion? Maximum possible rank of A is not at all 3. Not 3 at all. Because maximum possible rank of AB is 3. If maximum possible rank of AB is 3, rank of AB not equal to rank of A, then maximum possible rank of A is not at all 3. Will it be 4? Will it be 4? Not at all. Because rank of A not exceed rank of AB. So 3 is cancelled, 4 is cancelled. You have 1 or 2. It is not 3. If it is not 3, what is the next possibility? What is the next possibility? Either 1 or 2 or 0. So either 0 or 1 or 2. Which one is questioned? Highest. Highest possible. Therefore, highest possible rank of A equal to 2. Mr. Akhtar, rank of AB is not 3. Rank of AB is 3. Rank of A is not rank of AB. That's why it is not 3. उमेश, augmented मैट्रिक्स का डायमेंशन 4x4 आएगा ना? कैसा आएगा जी? किधर से आएगा? A और AB का डिफरेंस ओनली वन कॉलम एक्स्ट्रा. Column means it is not row. You should not increase row. You have to increase column. Observe this problem. It is also concept based question. Let A be n cross n real matrix such that A square equal to I. A is n cross n real matrix such that A square equal to I. Y be an n dimensional vector. Then the linear system of equations Ax equal to Y has. He has given one hint. With the help of that hint, we have to solve the problem. What is the hint? A square equal to I. Okay, concentrate. If it is given that first method, given that A square equal to I. If A square is I, what is determinant value of A square? Determinant value of I. Catch my point? If determinant value of I, A square equal to determinant value of I, det A into det A is 1. So det A whole square is 1. Det A is either 1 or minus 1. Det A not equal to 0. Det A not equal to 0. If det A is not equal to 0, the system possesses. If det A not equal to 0, then the system possesses unique solution. I have mentioned clearly. Det A not equal to 0, unique solution. Unique solution. That's why here you can write unique solution. Here you can write unique solution. Understood? This is first method. Now I am explaining second method. Second method. Matrix A is n cross n such that A square equal to I. Basha, look at the problem. That's why I am explaining second method. A is n cross n matrix such that A square equal to I. If A square is I, determinant value of A is either 1 or minus 1, that A is not equal to 0. Okay, we have one property. If that A is not equal to 0, matrix is non-singular. If matrix is non-singular, rank of A is its order. Okay, remember, rank of non-singular matrix is its order. It is non-singular. That's why rank of A equal to n. Rank of A is n. Observe here. This is 1 point. 1 point. Number of columns always declares number of columns in the coefficient matrix in Ax equal to B. Number of columns in the coefficient matrix always declares number of variables in the system. That's why I can write number of variables equal to m. This is another point you have to remember. Now I am going to derive third point. What is that third point? Observe. Observe. Matrix A is n cross n. Very conceptual. Matrix A is n cross n, where det A not equal to 0. Det A not equal to 0 means n cross n minor of A is non-zero. Na? A is n cross n matrix. Det A non-zero. Det A non-zero means n cross n minor. N cross n minor is non-zero. Got the clarity? If n cross n minor is non-zero, then only rank would be 1. Rank would be m. Catch my point? Now A is n cross n matrix is okay. If A is n cross n matrix, what about augmented matrix AB? What about augmented matrix AB? Augmented. I am talking about n cross n plus 1. Very good. N cross n plus 1. One column extra. Okay. Now, my point is, if you verify maximum possible minor of AB, what is maximum possible minor of AB? What is the maximum possible minor of AB? Maximum possible minor of AB is n or n cross n cross n. Maximum possible minor of AB is n cross n. In n cross n plus 1 matrix, you have how many n cross n minors? In n cross n plus 1 matrix, how many n cross n minors? 1 n plus 1. Yesterday I have explained you one formula also. You are going to select n cross n matlab from n you are going to select n, NCN. From n plus 1 you are going to select n plus 1 CN. So NCN is nothing but 1. n plus 1 CN is nothing but n plus 1. Total how many n cross n minors? N plus 1 minus. So in those n plus 1 n cross n minors, this minor is available or not? I mean A is available or not? A is available, na? A is available or not? Already that A non-zero. Therefore, whatever minor which is available in AB, that minor is also non-zero. If that is non-zero, rank of AB equal to n. Rank of A is n, rank of A is n, rank of AB is n, number of variables are n. All are equal. If all are equal, then you can say that the system possesses unique solution. Basha, understood? So whether it is homogeneous or non-homogeneous doesn't matter. Rank of A and rank of AB and the number of variables all are equal. Therefore, 100% unique solution. Okay. Remaining problems we can continue tomorrow. Now, some students have posted some queries. I would like to answer. Why don't you use determinant method? Where? Sir, can we say that two vectors are independent, then they are parallel? If they are independent, then they are parallel. Dependent, then they are parallel. Incorrect. Your assumption is incorrect. If they are parallel, matlab A bar, 2A bar are parallel. Okay. इंडिपेंडेंट मतलब पैरेलल नहीं, डोंट ट्रैप मी, ओके। डिपेंडेंट मतलब पैरेलल। अरे, which calculator I should use? This is not the relevant question for me. Nikhil, linear algebra, entire syllabus you have to practice. Calculus and vector calculus, linear algebra, calculus, vector calculus compulsory, differential equations compulsory, then Fourier probability statistics is there, complex variable is there. Nikhil, you have to attend entire syllabus, okay. The determinant value of skew symmetric matrix of odd order is always 0. Even order, no comment. Only odd order, correct. Odd order is 0 is correct. If even, then the value of determinant is 0 or not. If it is 0, I will give the property, na? You can't comment on that. Linearly independent solutions and independent solutions are different, not different, both are same. Independent solutions and independent variables, free variables, all are same. What is subspace? Sub part of the space are. लक्ष्य को लक्ष्य नहीं हो गए, ये रास्ता। सब पार्ट ऑफ द स्पेस किधर से आ गया? सबस्पेस वाला समझ दीजिए प्लीज। राजू कुमार, you watch the recorded video 5 times, you will get it. All the solutions of this workbook are available in this practice course. You watch the first lecture, because your problem number is 7, na? 7th problem I have solved in the first lecture. You watch it. Last question I did not understand, order of the augmented matrix. Orally, if A is 2 cross 2, AB is 2 cross 3, because one column you are adding to A. Adding to A means not addition, you are extra, because you are taking combiningly. Whether question number 6 or 7, you watch the recorded video of practice course, first lecture. I have covered already. Next. B is a basis of R square means it is a basis of subset of R square. First, you must be clear about your question. In last question, A was homogeneous or not. Whether it is homogeneous or non-homogeneous doesn't matter. Non-homogeneous or homogeneous. If det A not equal to 0, then 100% unique. It is in our problem set. You have to find out orthogonal vectors. Orthogonal vectors matlab dot product equal to 0. Dot product is 0 in the first option. For CSC syllabus, in CSC syllabus you have only 3 concepts: linear algebra, calculus, probability and stat. Only 3 concepts you have to attend. Okay? Which chapter? Yeah, I have answered. Previous query and this query both are same. Okay? Good night. Thank you.